Now here's the thing. This is why I call this natural forms, right? This is kind of an awkward way to say it. An awkward way to express this as this. It's true, it's right, but remember we said it's different, it's a new wave function, different in amplitude, okay, and also different in phase shift, right? Now this is a really long way to push sine to get it into the right spot, okay? It's plus, so that means I'm going to the left, okay? And you're going, 7/8 the way around to get all the way back to the actual graph that you want, right? So it's a really big angle to move it over. Sorry, it's that way, okay? So how can we get it looking more like this? Like a nice small angle, more specifically, an acute one. Richard? Say it again. Minus pi on 4. You're right that we have to minus something, but pi on 4 won't quite do it, because that'll be a different graph. Moving it pi on 4 will not make it equivalent. So we have to move it something. What else could we move it? Think about what sine looks like. And cosine is sort of similar in this respect. The period of sine is 2 pi, right? So therefore, for instance, if you get some value over here, okay, this is kind of equivalent to what we've done. It's really far over, right? If I want an equal angle, I just have to come backwards 2 pi, right? Because it's periodic. So if I go back 2 pi or 4 pi or whatever, still be the same answer, yeah? So another way I can write this is root 2 sine of x plus 7 pi on 4, but I'll go backwards 2 pi. Okay? Nod slowly at me if this is making sense. Shake your head at me if you're like, what are you doing? Okay, I'm going to stay with it for now. I'm going to show another way. Well, okay, alright, so, sorry, I see what you, right, sorry, I misunderstood what you meant. So when I evaluate this, then I'm going to get, so 7 pi on 4 minus 2 pi minus pi. Okay. Yeah, sorry. This is the important part. Okay, now, this is a better way to write it. This is a much better way to write it. Amplitude's the same. Amplitude can't actually be changed at all. But I can choose a different auxiliary angle, a better one which doesn't move me so far. Now I'm going to the right, pi on 4, 45 degrees, instead of going to the left. It's kind of like, if I want to turn right, you could do a Zoolander and turn left and go all the way around. It's kind of like, why would you do that? Okay. Oh, it's the other way around. Sorry. It's been many years since I watched that movie.
No,
so,
you got it right.
Did I?
Yeah.
I'm not going to get caught up in the details of a Ben Stiller movie. Anyway, you get the idea though, right? That moving just a little bit to the right is better than moving tons to the left. Okay? So, what you've got down here, this is the natural form for the auxiliary angle. Another way of remembering it is it's just what gives you an acute value for alpha. Okay? In the same way what I had up here, this is also the natural form, okay? But can you think of another one? What would be another way to write that one? There's an infinite number of ways. I could subtract 2 pi again, right? This would also be equivalent to this, right? That's another way to write it, but it's not as good. This is a more efficient way to write it, okay? So, let me show you this one more way, apart from shifting it across. Let's go back to trig expansions, okay, and the way each of the trig expansions works. Okay, now this is just reciting the expansions, right? But I want to draw out something important here. When you have a look at this first one, right? The kinds of original wave functions, right? Like say sine x plus cos x. That's what we started with. That was our first one, right? The reason why I know it naturally fits better in this one is because look at the signs, positive or negative, of the coefficients you have here, right? You've got positive, positive, right? So therefore, I'm going to look at this one. This is the natural form because the coefficients, their signs, match these ones, positive, positive, right? It wouldn't make that much sense to go from here to this because you've got to turn positive, positive into positive, negative. In exactly the same way, but in reverse, when we dealt with this question, okay, we should think, well, look, I go positive, negative. Which expansion will give me that more effectively? Well, this one, right? Because if I write it like this, what you can avoid is when I put my coefficients out the front and make it really obvious. Okay, if I use this second expansion here, okay, I'm going to have cos and sin. Okay, so do you see here now, I don't have to do that awkward plus -1, right? I can just say, look, this is 1, that's going to be 1. This is minus, that's minus, so this is also going to be 1. It just transfers straight across, okay? Now, these are the natural forms for sine. There are two more trig functions that we can use, right? Namely, cos for plus and cos for minus, okay? So there are 4 natural forms. There's 1, 2. How do we actually write it out? If you see positive coefficients, okay, let me put it in a different color. If you see positive coefficients like this, A, B. Okay, so A and B are positive, there's a plus in between. The one that you go for is sine x plus alpha. Okay, that's the natural form. If on the other hand, there's a minus. The minus over here translates to a minus up here, because when it expands out, the negatives will match up together. Okay, now in what cases would you want to use cosine? Remember what the cosine trig expansion looks like? If you take r cos x plus alpha, okay, what you're going to get, sorry, just 2, is, who remembers the expansion? Okay, yeah, good. Because this one's mixed up, right? Cos is not with it all together. So cos goes first, cos x, cos alpha, and, sorry, it's a minus, sine x, sine alpha. So what would you expect? What kind of wave functions would you expect lead you naturally to use cosine? Well, the first thing that I noticed that's different is that here in these expansions, right, sine is first and then cosine is second, right? Well, here, cosine is first and sine is second. It's the x terms I'm interested in, right? So therefore, I'm going to use it when cos is first, sine is second, and there's a minus sign in between, right? So if you see something like this, a cos x minus b sine x, okay? See the subtle difference between these two, okay? Therefore, what I'm going to go for is r cos x plus alpha, all right? Now, if I'm adding them, instead of taking the difference, okay, in order to turn this minus into a plus, because cos is reversed, right? So I'm going to use this form. Make sense?